Hi, I am Frances Campoy, and this is Just for Funk. So, hello, and welcome to episode number 9 of Just for Funk. Today, we're going to be talking about context. We're going to be covering what is a context value exactly, how to create values to pass them to functions that require them, how to define functions that receive those context values, and then also how context can make your HTTP clients and servers more efficient and less wasteful. So let's get started with the theory. So even though the context package was only added to the Go standard library with Go 1.7, the package itself existed way before. Before being in the standard library was under golang.org/x/net/context. And even before that, there was an internal implementation with a very similar API that we used at Google. The implementation itself has changed completely, but the API is actually incredibly similar. Some tiny little things that have changed. It is a very simple package. It has around 500 lines of code, so really not that many. And I encourage you to go and read the package. Maybe I might do an episode on this, on the insights of the context package. But today we're going to be learning about how to use it and why to use it, why you should use it. There's a main usage that is important for us, which is cancellation and cancellation propagation. So what does that even mean? So cancellation is when you are requesting some service, you can say, actually, never mind, right? So let's get an example. Imagine that you ask me to go make you a sandwich, right? And for me to make a sandwich for you, it will take me a bunch of steps. I will need to go buy some bread, then buy some tomatoes, buy some whatever, ham or whatever, and then put everything together, then pack it and give it to you, right? Like there's a bunch of steps. If at some point you are like, hey, you know what? I actually don't want that sandwich anymore. I should be able to stop everything that I was doing, right? Even if I already started and I'm on my way to buy tomatoes, I should be able to stop it. That's what we call cancellation. And cancellation propagation means that if I actually ask someone else to go buy those tomatoes, I should be able to say to that other person, hey, actually, I don't need those tomatoes anymore because I do not need to make the sandwich, right? So you have cancellation and propagation, two different things that are very related, really. Then on the other side, there's one more thing that contexts do, which is to send values. And those values are very useful, especially for like if you want to log stuff. And we will talk a little bit about how to use them at the end of the video. But we're going to concentrate mainly on the cancellation and propagation sides of the context. Cool? Okay, so let's get started with a little bit more of code. Okay, so if we go to the documentation in the standard library for the package context, you will see that there's actually two types that are exported. One, it's just exported for documentation purposes. It's cancelfunc, and we'll see what it does later on, but you should not care about it that much. The important one is the context type. So there's a context type in the context package that is an interface, and it has 4 methods. So there's 3 methods that are related to cancellation and propagation, and 1 method that is related to values, value propagation. Okay, so this means that if we have a function that receives a context, we need to send a context value. But if we have an interface, how do we create new values? There's actually a bunch of functions that are specifically designed for that. The first one is context.background. And background is when you have a context that you're not reacting to anything. You're not reacting to anything else. You're just starting the action, right? And on top of that, you don't need any cancellation or timeout or values. You just create the root context, right? And there's actually one root context, which is background. The rest is just children created from that root context. And it's important to hear that root and children, because actually what we're creating is a tree of context. If I say, please make a sandwich, and then you say to someone else, please go buy tomatoes, that is actually creating kind of a tree of dependencies or a tree of requests that we're sending, right? Context will follow the same structure of tree. Okay, so let's try to use that context.background. To define it, we simply call context.background. And there you go. Now we have a context.background. I have defined a function called sleep and talk. And if we read the documentation for that, you will see that sleep and talk gets 3 parameters: a context, a time that it should sleep, and then a message that will print after sleeping for that time, right? So we could say it was gonna pass a context, and we'll define it in a second. And after 5 seconds, you should print hello. Now, that context, we're gonna use context.background, as we said before, if I'm able to type it. There you go. So context.background will never be canceled, which means that if we run this, whoops, that is very big. Go run. You should see after 5 seconds, it prints hello. Cool. Now, what else we could do? Well, we might want to cancel this eventually, right? Okay, so let's say that, for instance, we want to cancel as soon as we are able to read something from standard input. So we could say we're gonna create a new context that is a child of the previous context, the context of background, but now we're gonna add cancellation to it. So we're gonna call context with cancel of context. And we're gonna pass that context that provides cancellation to this. We're gonna read from standard input. We're gonna create a new reader, a new scanner, why not? A new scanner. And we're gonna scan. Okay, so cancel is never used. Okay, so as soon as we're able to read anything, we should cancel. Okay, so now what we have here is if we don't do anything, after 5 seconds, this should print hello and finish. There you go. But if for any reason we type something, we cancel that context. So we're able to stop the sleep and talk function to just stop it directly by canceling the context, which is pretty cool, right? So you can do these things where you have a cancellation and you're the one managing when to cancel that given context. Now, imagine that instead of doing this, you wanted to cancel it after sleeping for 5 seconds. So you could do something like this, right? Like you could do time sleep time.second. So you sleep for a second, then you cancel it. This is pretty similar. It's a simpler code, but now it's wait for a second and then cancels it. Since sleep on talk is waiting for 5 seconds, we will cancel the context every time before anything gets printed. We could write this in a better way, simply saying time after func. And time after func will do exactly that. So it will say after 1 second, please call cancel. This is exactly the same code, right? So again, if we run it, we'll get the same result. Now the cool thing is that you could simply say, what I'm gonna do is I'm gonna do context with timeout. And timeout gets the context and also the duration. So now we also get very similar code as before, but now we can drop all of this. And important thing, we actually need to call that cancel regardless of if we care about it or not. So what we can do is defer calling that cancel function at the end. This is important because the context package will allocate some resources for timers. And when you call cancel, those timers will be released. So it's important to do it. So we've seen the 3 ways of creating context. Context of background, with cancel, or with timeout. You could also use with deadline, and with deadline, you could say, actually, I want it to stop today at 5 p.m. It's pretty much the same idea. It's basically parallel ways of setting timeouts. Okay, so how do we use that context inside of our function? So let's try to define that same function here. So I'm gonna call it my sleep and talk. So the parameters are a context.context, duration, and a string. So what we can say is I want to sleep for D and then print message, right? And I'm gonna call my sleep and talk. So if we do this, even though we're canceling the context, nothing happens. And we still wait for 5 seconds until we call hello. We print hello. Why is this? Well, because we didn't do anything, right? Like we get a context, but we're ignoring it. So what we need to do is we need to verify if that context for any reason was canceled, right? We want to do that at the same time that we want to sleep. So either we wait until we're done sleeping, or the context is closed. How do we do it? Well, luckily for us, the time package allows you to, rather than do sleep, to get a channel that will receive a value only after a given duration. So all of a sudden we have two different channel operations that we want to do exactly at the same time, and for that we can use select. So we're gonna change this time.sleep for time.after, and you can see that it returns a channel of times. And we're gonna do select. So if we're able to read from that, then we print, right? This is exactly the same code as before. So far we haven't changed anything. So if we run this, we should be able to see that after 5 seconds it prints hello. We changed a little bit of our code, but we still not taking into account the context. But now it is actually very simple. We can say if context.done, we can read something, we're gonna log context.error. And now, all of a sudden, after 1 second, we print context deadline exceeded. If we were actually calling cancel directly, we could instead get a context cancel. Those are the two errors that we mentioned at the beginning. Cool. So now we're able to see how to send values, how to send context values, and how to receive them and handling correctly internally. You could also do pretty much the same thing and pass those contexts around and create new ones. But I think the most interesting part here is the fact that you can create new deadlines and timeouts and cancellations at any single step and just pass those around. If for any reason the context on top gets canceled, that cancellation will propagate to all the children context, and all of those operations will stop. Great. And that works very well here on my laptop running code that only runs in a single process, right? What happens if you're doing communication over the network? What happens if you're doing HTTP? Well, let's see that, because this is actually the coolest part of all. So I'm going to create two directories. I'm going to create server, and I'm going to create client, that is here, and my client. So let's start with a server. We're going to create .go, and that's going to be your day-to-day HTTP server. So handle func everything with handler, and then log fatal of HTTP listen and serve of 127.0.0.1.80.80 and nil. And then we need to define HTTP handler. It's gonna call it handler, and this is gonna simply say fprintln hello. Cool. And define HTTP handle is a composer. Handle func. There you go. That's better. Cool. So we have a very simple. Actually, let's log something here. Handler started and defer handler ended. Okay. So with this code, what we're doing is whenever we receive a request, we just print hello back to it. But also we're going to be able to print handler started and handler ended once we're done. Let's make this very, very slow so we can actually see how this works. So we're going to just simply add time.sleep. Time.sleep, 5 seconds. Okay, so let's try it first. I'm going to run that server. And now it's running. And if I do curl localhost 8080, should wait for 5 seconds and then print hello. And here we should be able to see handler started, handle ended after 5 seconds. So you're able to see everything. Everything is working. Cool. So now let's write a client that calls this server. So I'm gonna go back here and I'm gonna create a new file. Whoops, not a new folder, but a new file. Main.go, package main, func main, and http get localhost 8080. Nothing. Get localhost http localhost 8080. Okay, cool. And that will give response and an error. If there is no nil, we should log fatal error. Otherwise, we're going to check if the status, actually let me autocomplete. If status code is not HTTP status okay, we should log fatal the status, and we're getting panics. I'll fix that in a second. Okay, status code, and otherwise we will copy to the standard output the body of the response, and remember to close the body of the response. Cool. So we have now the client. Let's try it. So we go to client. This runs. It doesn't work because our server is not running. So let's run the server. And now the client runs. Waits for 5 seconds. It should print after 5 seconds. Hello. Great. Okay, so let's now add some context handling on the server. So what context, right? Like, should we use background here? There's no context. There's actually a context, which is hidden here inside of the request. So that is our context. And now instead of sleeping for that time, we're gonna do something very similar, right? We're gonna do our select, it's gonna be here. We're gonna use time.after. So that's gonna be our case reading from there. Just print hello. Case receiving from context.done. We can do let's simply call, so we're gonna log something, log printf context.error, but also we're going to return http error of error.error, and let's say internal server error, which is not really the case, but we should be okay. Print http error is not happy because that is context.r.error. Not very happy with that. Let me write that there. Okay, cool. So now a server, what it's gonna do is if we cancel it, we'll be able to say, you know, you need to stop, and it will return an internal status internal server error page rather than going through the whole operation, which is cool, right? But there's actually something even cooler, which is when we run the server now. So if we send a request, say handler started, waits for 5 seconds, and it exits. What is cool is that if we cancel it here, so we cancel the curl, we drop that connection, the server will also receive a context cancellation. And that is awesome, because what it means is that all of your HTTP servers now, they're able to stop processing the task that they were asked to do if they know that the client will never receive it. So all of a sudden, imagine that if you were doing something actually expensive, not just time.sleep, but you were doing something like polling some server or going through a bunch of data files or through a database, you do not need to do this if the client will not receive it. And now you have a very clear indication of that with context, which is awesome. Great. So we have that, but how do we use that from the client? In our client, what we can do is, as we were doing before, we can create a context. And where do we put it, right? Like there's no place for context here. So what we need to do is we need to separate this HTTP GET into two steps. We need to first create the request and then send the request. So we're gonna create a new request with method get. The URL is gonna be the same one as before and no body. That's gonna be our request, and that could fail. If it fails, we're just gonna log fatal that. If it fails, it's because either the method doesn't exist or the URL is not really a URL. So that should never happen really in this case. Okay, so now this will do http.defaultClient.do of the request. And request dot with context will allow you to create a new request that has the request in there. Let me say that again. With context, we'll create a new request that has a context inside. So you could be wondering here, why isn't there a context field in the request struct? And actually the main reason is because if you added that, then we could break the 1.0 compatibility, right? Because imagine that you're creating for some reason, you're creating a request and all of a sudden you add one more method and your code might break because if you're defining a request without using tags, which you should not, but you might, if you did that, then all of a sudden there's one more field to declare, which means that everything breaks. Sad, but that's how it is. So instead, that's what we have with context to set the context and context to retrieve it. It's kind of like get and set, really. Okay, so we do with context of the context, we'll get a new request, and now we're sending it. So now this code doesn't do anything extra, anything new, right? So if we run it, we go to the client, go run main.go. This will still wait for 5 seconds and then finish it, and then print hello. But we can now very simply add a context cancel, context with timeout, context time.second, defer cancel, right? As we did before. And now if we run this, we will see that after 1 second, we already returned here content deadline exceeded, and our server also said the context has been canceled, right? Which is pretty nice. So now all of a sudden you get all of this power of being able to cancel operations as soon as they're not needed anymore. And this implies adding some extra functionality here. And it means that very often you're gonna need to add channels. So you're gonna be able to do that select statement. But in exchange, you're actually getting way less resource wasting, because now you're able to notice that all the work that you're doing is completely pointless, so there's no point on bringing them a sandwich if they will not be there anymore. Okay, so we've talked so far about cancellation and propagation of that cancellation, also known as cascading. Basically, if I cancel, whoever was using the same context as I was will also be canceled. Cool. So what about values? Well, the first thing to understand about values is that they're probably not a great idea to be used. And if you're considering using values, before doing it, think about if it's really something that it is what we call request scoped, meaning that if it's something that it is not only related to that request, so for instance, let's say it's some option on the server or even a database connection, should not be in the context. That should be in a server type or some flags, maybe even a global variable, but not in the context. And if it's something that is related to the specific request, but it is something that it is important enough, like let's say it is something that you're gonna act on, it should be a parameter. It should not be in the context. Why? Because in the context, everything you put in there is completely invisible, right? So very easily, if you start putting too much stuff in there, you will get to a point where it's actually hard to follow what your code is doing. So the two rules, basically, I'd say are, one, whatever is in the context should be request specific. And 2, whatever is in the context should be information that adds information, it's extra info that is useful, but does not impact the flow of your program. So, knowing this, what could we use that as an example? A very good example for this could be, for instance, request ID. Like, if you're logging all the things that your program does, you might want to have a request ID to identify in a single server all the things that are related to one single request. Can you do that? Well, actually, it's pretty simple, and that's what we're going to be doing now. So, I'm going to start by creating a new package. I'm going to call it, let's call it log. And instead of log, we're going to have a main log.go. Okay, so in that package, what we're going to have is we're going to define a println function that, on top of receiving the message to print, is also going to receive a context, right? So message string, and what we're going to do is we're going to get a value from that context that we're going to use to identify what we're printing, right? So we're going to do, let me save that. So context value, and we need to get a request ID key. That request ID key, we can say const request ID key is 42. Let's say it's 42, whatever. Any number could work, right? And that will return an empty interface. So what is that empty interface? Well, it could be nil if we didn't find it, or it should be whatever we put in there. So let's say that it is also an integer. It's an int64 for some long request, right? So we could do int64 and then say that that is the ID. But then it means that if for any reason the value in there is not good, or the value is not there, so if the value is not there or it's the wrong type, this will panic. So we can add OK. So if not OK, then we could actually print something saying println could not find request ID in context. Okay, and return. It doesn't print anything because it doesn't know what to print. We could do that, and otherwise it prints the value and the message. So ID and message. Cool. So this is the part where we're retrieving the value, but we still need to put it in there. So when do we put it in there? So we could have a function that, given a context, we add a new context, but this is actually something that people might forget to call. So instead, what we can do is we can create what we call an HTTP decorator, or basically just a wrapper of an HTTP handler func. So I'm going to call it decorate. And given an HTTP handler func, it will return an HTTP handler func. Okay, so what do we want to do there? We want to return an HTTP handler func. And this HTTP handler func, I'm going to say it so many times. The first thing it does is it generates a random number. Actually, the first thing it does, it gets the context from the request. So context. And the next step is going to use int63 to generate a new number. That's going to be our ID. That returns an int64, so it's going to be some random number. And next step is going to put it in the context. So it's going to do context with value of the previous context, and then our key, and then the ID. And now we want to use that new context inside of a request to call the previous handler func. So we're going to call f with the same response writer, but with a request with context. So now we are receiving a context, adding a value, and sending it back. Okay? So how are we going to use this from the server now? So if we go here, the first thing is we're going to drop the log here, and we're going to be using my amazing log. Justforfunc context. Oh, it was there. Justforfunc context log that has log.decorate. So we can decorate a handler, and it returns another handler, so this still works. Our print will now require context, context, and context. Oh, and this needs to be a string, so we'll need to call error. Okay, so now we didn't do much really, right? But all of a sudden, without knowing our code, the handler code doesn't know about that key at all. But it is not important, because when we run our code, go run main.go, and we do a curl on localhost 8080, we can see that that request there, it is a new request that was generated randomly. And every new request will have a different request ID, which is pretty nice. Okay, so now this works, but there's a little bit of an issue, which is it could be quite easy that someone else in the world decides to use the same key as I did, the integer 42. And then we could have collisions. So for instance, we can fake that by saying context with value of context, and we're gonna use the same int 42 as before, but now we're gonna use an int 64 that is gonna be 100, right? And now if we run our server, so go run main.go, and we send the request, you will see that we get 100 all the time, which is not what we want. But at the same time, how did this code know that it was int 30, like an int with the value 42? That was our key, right? The chances of having a collision are pretty big. But we can avoid this very easily, simply by making this value of a type that we do not export. So now I'm going to say type key is an int, and the request ID key is of type key. Now this key is a type that only the log package can use. So if we rerun our program here, the problem is gone. And even better, there's absolutely no way that this code could clash with what the log package is doing, which is exactly what you're looking for. So this is actually a pretty nice side effect of two different values of different types being always different when you compare them as interfaces. It is a side effect that sometimes is a little bit surprising, but in this case, makes it for a very nice experience. Okay, so this is pretty nice, and it shows you how you can send values across functions that do not really know about them and they don't really care. But what about when you want to send them from one server to another? Will this just work? We can try it. We can say our main.go, we're gonna add our client, we're gonna add value. So we're gonna do context with value. And let's say that we're gonna attach to the key foo the value bar. And then from here, we can try from our client, we can try to get that value by saying context.value of foo. And we're just gonna print it to the output. Printf value for foo is that thing. So now if this works, we should be able to run our server, run our client, and see here that the value for foo is nil. So this does not work. But there's a good reason for this, which is if you actually want all of those values to be sent across servers, you will need to write that code. It's actually not that hard, and you could definitely encode this and send it as a header. Probably request ID could be a great header to send, but you will need to add that code. The HTTP package will not do it. Unlike with cancellation, where it will actually go over different servers because the TCP connection drops, and that is the information we're using. For other things like values, we do not propagate them. So it's important to take that into account. Great. So this is the end of this episode. I think that we covered the basics of the context package. Now I hope that you all know what the context package does, why would you use it, how to use it, and what are the limitations. I hope that you enjoyed this episode. Let me know if there's anything else that you might want to learn about the context package. I will be working on the next episode that will come out in 15 days, as always. And by then I will be in China for GopherCon China. So if you're in Shanghai, please let me know. And I'm thinking that that episode will be, again, a code review. So send me your packages. Send me if you have a repo that is simple enough, but not too simple that you think might be a good thing to read and to evaluate during around 30 minutes, send it my way. You can send it through Twitter. I'm on Twitter as Francesc. Or you can just simply put a comment down here. And now that we talked about things around here, click subscribe. I keep on having more and more followers, which is awesome. I love your comments. I love your feedback. So please keep it coming. So, as always, thanks for watching and see you all in 2 weeks.